You know, the world around us, it's just this constant flowing stream of information, right? Sound, light, heat, it's all happening all the time. So to capture any of it, to record it or send it somewhere else, we have to make a copy. But how in the world do you make a perfect copy of something that never, ever stops changing? That's the huge challenge we're going to dive into today.
I mean, really, think about that for a second. How can one little groove, a single wiggly line in a piece of plastic, possibly hold all of that? The boom of the timpani, the soft whisper of a flute, the soaring strings, everything all at once in perfect harmony. How does it do that?
Well, the secret is right there, in that groove. It's not just some random scratch. No. It's an incredibly detailed physical copy of the sound wave itself. It's a continuous signal that perfectly mirrors the original performance. And that is the magic of analog.
So what exactly is an analog signal? The easiest way to think about it is like an electrical mirror of reality. When a singer's voice goes up in pitch, the signal's voltage goes up with it. When a drummer hits the snare, the current pulses at that exact same moment. It's a direct, one-to-one translation of a real-world event into electricity, capturing every single smooth, continuous detail along the way.
And once you start looking for it, you realize this brilliant idea is, well, it's everywhere. It's in the radio waves bringing music to your car, it's the tech behind old broadcast TV, and yeah, as we've seen, it is literally carved into the grooves of a vinyl record. Even when you just speak into a simple microphone, you're creating an analog signal.
But here's the catch. There's a problem, a big one. This beautiful, perfect copy of reality, it's incredibly fragile. It has a natural predator that's always lurking, in every wire, every circuit, even in the air all around us.
And that enemy has a name: noise. You know it well. It's that static you hear between radio stations, that faint hiss on an old cassette tape, the snow on a weak TV signal. Noise is just any random energy that gets mixed in with our signal, and its only job is to corrupt that perfect copy, distorting it and eating away at its clarity.
So take a look here. On the left, that's our pure signal. Smooth, elegant, right? A perfect representation. But then on the right, well, that's what happens after noise gets its hands on it. It's the same basic wave, sure, but now it's all jagged and fuzzy and distorted. The original perfection is gone.
So the quality of an analog signal really comes down to three things. You've got amplitude, which is its strength, think of it as volume. You've got frequency, which is how fast it changes, kind of like its pitch. And then you have the big one, noise. And here's the killer part. Once noise gets into an analog signal, the system has no way of telling what was the original signal and what's the unwanted interference. The corruption is baked in. It's permanent.
This huge weakness, this vulnerability to noise, it got engineers thinking. They started asking a really fundamental question. What if, instead of trying to protect this one perfect fragile copy, what if we tried a completely different strategy altogether?
And that thought process, well, it brings us to the great rival, the challenger that completely reimagined how we copy reality, the digital signal.
This is such a brilliant way to picture the difference. Think of analog as a master painter, trying to capture a landscape with a free hand, using infinite shades of color and smooth, flowing brushstrokes. Digital, on the other hand, is like a paint-by-numbers kit. It ignores all that infinite flow. Instead, it takes thousands of tiny snapshots every second and just assigns a number, a code of ones and zeros, to the color of each little dot.
All right, so let's put them head to head. The big showdown. We're going to look at three things: fidelity, how accurate the copy is; cost, how much it sets you back; and maintainability, how well it holds up. You'll see pretty quickly that there's no simple winner here. Each one has its own game plan. So, let's break it down.
First up is fidelity. Now, analog, in theory, is perfect. It captures everything. But the problem is, in the real world, every single time you copy it, you add a little more noise. The quality gets worse with each generation. Digital? It's a totally different story. Sure, it's an approximation, it's not the real thing. But because it's just a list of numbers, you can copy it a billion times, and that billionth copy is exactly the same as the first. It's all about resilience over that initial fragile purity.
Okay, but what about the cost? Which one's cheaper? Well, if you're doing something really simple, like just making a sound a little bit louder with an amplifier, analog is usually cheaper. But the second you want to do something complicated, like storing an entire movie or adding studio effects to a song, digital wins, hands down. It's just way more cost-effective to mess with numbers than it is to manipulate a delicate electrical wave.
And finally, how well do they hold up over time? The maintenance battle. Analog stuff wears out.
Components get old, they drift with temperature. A vinyl record gets scratched, a cassette tape gets thin. Digital, though, it's rock solid. A 1 is always a 1, and a 0 is always a 0. The data on your phone doesn't drift. It's either there perfectly or it's not. It's incredibly stable and super easy to check for errors.
So at the end of the day, who wins the fight? Well, the truth is, nobody. There isn't a single champion. The best technology is just the right tool for the right job. Are you looking for that potential for absolute, nuanced perfection, and are you willing to protect it? Or do you need a copy that's tough, reliable, and easy to manipulate?
You know, this quote just sums it all up perfectly. Analog is this constant search for a flawless but ultimately fragile mirror of the real world. Digital is all about creating a tough, practical, and basically immortal blueprint. They're just two completely different philosophies for capturing our world. And all of this leaves us with one last thing to chew on. As our world gets more and more digital, filled with these perfect, repeatable copies, are we losing something in the translation? You know, those subtle details, that famous analog warmth, those priceless little imperfections that make that flawed copy so beautiful. Can you really capture all of that in a paint-by-numbers world? It's definitely something to think about.